Welcome to our podcast.
Yes, I'm Taylor.
I'm Elyssa, and we're the Exploreum's podcast group.
Yep.
This is episode number 2. We're still just figuring it out.
Yep.
Not scientists. Disclaimer.
We are
Just figuring it
definitely
out.
not
We're
scientists.
silly little scientists that don't know what we're doing, so it's all good. Today's topic is going to be 3D printing.
Yes.
Because in the history of 3D printing, it has been something that has grown tremendously, especially in this kind of like past 20 years.
Yeah.
It's been getting bigger and bigger and bigger to where people are now building their own Ferraris and they're building all sorts of stuff. So
That's crazy.
here at the Exploreum, we have 3D printers ourselves. We do a lot of with our 3D printers. We're very, very blessed to have them at our AM&S. The AM&S Calvert STEM Lab. They helped us out a lot with it, and we are very blessed to have it along with all the 3D printers. The guy who runs it is named Bruce, and Bruce unfortunately couldn't be here today, otherwise we would love to have him, but he did answer some questions for us.
Yes.
So I have, of course, color-coded questions because we are colorful people.
Yes.
Question number 1 is, could you give us a brief overview of what 3D printing is and just kind of how it works?
Yep. From the wise words of Bruce, 3D printing is the process of taking a digital 3D object that you or someone else designed using a program such as CAD.
CAD?
Mm-hmm.
Okay.
And bringing the object physically into the real world using a printer that prints the objects in numerous layers.
Okay. So CAD as CAD, I'm assuming, is going to be a program on the computer that you have to download, and then it has all the tools that you need
Pretty
to
much.
create in that program. Then you just send it to the printer, and the printer does the work for you.
Yes.
And it's just tiny layer by layer of just plastic.
Mm-hmm.
Okay. So question number 2. What made you interested in 3D printing, and how did you start out?
I began my interest in 3D printing from a previous STEM coordinator at the Exploreum Science Center.
Okay.
He was in charge of teaching the 3D printing camp at the time. If I say I, that means Bruce.
Yes.
I was an exhibit maintenance IT tech, and technology has been fascinating to me. I decided to check out what he was doing with 3D printing one day and learned what I could from him. I eventually learned enough to where I was checking the 3D printers before the 3D printing camp began for the summer to make sure everything functioned correctly.
So just to kind of clarify, there was a guy that was here
Yes.
before Bruce that was in charge of the 3D printers and the camps.
Yes.
And then Bruce got really interested in what he was doing, wanted to like figure it out because it just seemed something really neat and cool. I don't really blame him. 3D printing is awesome.
Yes.
And then, so once Bruce decided to check it out, he eventually learned enough about it to check on the 3D printers and then make sure everything worked before the camps began.
Yes.
Because Bruce is insanely smart.
Yes.
He is one of the smartest guys I have ever known. And I could definitely see him kind of getting curious and going in and just kind of figuring it out.
Just going for it.
Just going for it. That's all we have to do. That's all you have to do.
Just do it!
Next question. What resources, such as online tutorials or communities, did you find most helpful when you were starting out 3D printing?
Bruce found that YouTube, Google, and various forums really helped him learn more about what the do's and don'ts of 3D printing. So pretty much just online. He went and did his research on a bunch of different platforms to learn how to do it himself.
Which honestly is the best way to learn nowadays.
Yeah.
There is so much on YouTube that
know.
it's mind-boggling. I mean, you can learn anything you want on YouTube. I learned how to do bobbin lacing, which is lace making pre-industrial age, through YouTube, of all things. So I can definitely understand how someone could just go from nothing, start on YouTube, get resources like that, and then do their own research and just kind of gradually build. Who needs a degree when you have YouTube?
Yeah.
Just kidding.
Yeah.
Get education, kids.
Yes.
Education is important.
Yes, it is.
Yes. Next question. How did you, as in Bruce, come up with the ideas for different 3D printing projects, and what was his creative process like?
So, from, again, the words of Bruce, I typically Blah, 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 blah. I typically come up with ideas based on the task or objective at hand. If the objective involves something that kids will be partaking in, the idea has to be something fun that I think the kids will like and something that they have never seen or done before. So majority of my ideas are from scratch, but I'm certainly not above finding some related content to get the ideas in my head flowing. Then it is necessary that I change the content into something of my own flavor and style.
It's kind of fun to imagine and to think and to have fun.
It's the same thing when I draw.
Very true.
Yep, you find
every
inspiration.
artist has their own creative process. For mine, for example, whenever I'm painting, I first think of colors, and then I try to figure out what, if I do a wave, okay, what goes in a wave? A swirl.
Yep.
What kind of swirl? What color of swirl would go good with that color? And it just kind of goes from there. So his process basically is just taking in information around him from different resources like YouTube, and then putting his own flair into it, and something that kids would enjoy doing. And we do have a few things that have been made in our 3D camps that we're going to show a little later on. And to be honest, they are so impressive. Like,
they're
these
so
kids,
cute.
honestly,
They're so
the
cute.
way the creative minds of the next generation works is insane. It's amazing. But that's a sneak peek for later. Next question, that's the wrong one, is going to be, what are some challenges or obstacles that Bruce has encountered while working on a project, and like, how did he solve that issue?
All right, so when it came to obstacles or challenges Bruce encountered during his times of 3D printing, the issue rarely lies within the digital portion of the process.
So not much in the coding, more on the physical
Yes.
aspect. Okay.
Yes. Some challenges and issues that are common that he's had to solve are the print will not stick to the bed. His solution normally is using some type of glue or painter's tape.
Okay, so
I'm assuming putting it on the bed.
Yeah, so
it stays in place.
I have done a few 3D prints before, and I completely understand what he's saying about this, because it's very, very frustrating. Because you know when plastic, it melts, or like it's really hot in the sun, it's bendy and everything, and then it curls? Basically, that's what's happening here, is that the filament is plastic, and so it gets so hot, and then once it dries, it curls because it has to stay flat.
Gotcha.
What it means by not sticking to the bed is that the bed is the flat part that it prints onto, and it's normally really sticky, so it stays flat. And when it curls up...
Well, I was going to say that's the next thing you talked about is the print curling.
Yeah, so what does he say about it?
Well, the print is curling. A solution for this depends on the filament type being used.
Okay.
With PLA.
PLA.
With PLA.
PLA is a certain type of filament.
PLA. Yeah. The temperature is to hot the object, heat the object, maybe? Hot the object.
Put a comma in there. If the temperature is too hot,
thank you. Okay, yes,
will
yes,
curl
yes.
on the bed.
With ABS or
Yes.
abs. If temperature is too low, the object will curl. So adjusting the temperature in the program or on the printer will help. I'm going to the gym. That's why all of them have
Yes, that's why it's curling. It's just too strong.
Yes.
And then he continues to say, curling can also happen if the nozzle is too far from the bed. So if it's not flush on the bed, then it can just curl as it's going down. So it has to be a certain distance from the bed in order for it to lay flat. Then the solution, of course, is to bring the bed up to the nozzle. That way it won't curl as it's going down.
Gotcha.
The next problem that he had is...
bed is too close to the extruder nozzle.
So is the
or
opposite.
Uneven. With the QUBD, QUBD,
That's the bed.
Revolution printers.
So that's the name of some kind of printers.
The QUBD.
The QUBD.
Had to
Revolution
bend
printer.
the stop on... Whoa.
Okay, so what he's saying is if it's on those kind of printers, you had to bend the stop on the axis of Z, axis to stop switch. So basically, axis Z is going from up and down. That's the axis Z. So you have to bend the stop on Access Z on those type of printers. I'm not quite sure what that means. I'm just trying to explain from what is on here.
It says
Those
with
are
the
ones we have right now,
printers, they have self-leveling.
which is really useful.
Yes, that seems like it would be.
So our printers, what we have is the we have the MakerBots, which is the self-leveling, which is super, super useful. And we also have the Anycube Mega S. Those you have to level each corner accordingly to make sure it's completely even. There's certain ways you can do that. It's just a whole process of doing it before. That's what he used to do for the 3D printing camps before he took over the program.
Cool.
Yeah.
All right. Well.
And then some other problems that can occur are the nozzle is too clogged, which means that it's stuck up on in there and you have to try to get it out. Or the tape is not sticking to the bed, meaning even when you try to keep it from curling, the plastic from curling, it's just bringing up the tape with it instead of it staying flat. The tape's just going along with it. And then, of course, sometimes the filament snaps. So that means whenever it's going inside the tube to go melt it into the extruder, it snaps and then you got nothing coming out. It's just hot air. The next problem is the extruder is trying to print in the air. That is whenever it misses or it doesn't stick to the next level and it's just hanging there. It's just printing in air. There's nothing it's attaching to. It's just stuck and going woo. The final problem that he has experienced is the filament spool has a kink in it.
One eternity later.
Okay, so we are going to be switching roles for just a bit. I did the first half. Now Taylor is going to do the second half of the question. So we are on our next question.
All right. Fake Bruce, have you seen any crazy and impressive 3D printing projects or designs recently?
So he says, recently the most impressive 3D printing project that he has seen was a wearable suit someone 3D printed of Iron Man.
Oh, that is so cool. That is
Can
so
you
cool.
imagine making your own Iron Man? I would feel just like Tony Stark. Oh my gosh.
I know. I hope he has the Jarvis open. Like, and it opens
Yeah.
like that is sick.
But he continues to say he has seen cement houses that were 3D printed and then 3D printed prosthetic limbs. You know, I bet that is so useful because you can customize it. You can have it fit
exactly,
just how you need it.
Exactly to like
That's
the place.
impressive.
Yeah, that would
But
be.
I guess it would be a little difficult to get it perfect because you would need, in order to get it like a perfect fit, you would need to do a cast of the limb.
Well, I'm sure that's what they do.
But then how do you get the dimensions? I guess that's their problem.
Yeah. We are not scientists.
We color, they math.
Yes.
That's our motto. We color, they math. Oh, God.
All
What's
right.
your next question?
Can you explain some of the different types of 3D printing technologies and their unique characteristics?
Okay. He says that there are 7 main types of 3D printing and more than 20 subtypes of 3D printing technology used today. That's
Don't worry,
lot.
we're not going to give you
that's
all of those.
Too many to go over.
No.
But just like the main points are material extrusion. So material extrusion is exactly what the name suggests, basically. It's the most common 3D printing material. It is extruded through the nozzle that's heated. It's like 400 degrees or something. It's really hot. And then it melts the material in the process into the design or shape that you want. You can extrude different materials such as plastic, metal, paste, concrete, biogels, and even food.
Huh.
Can you imagine eating 3D
No,
food?
I don't think I'd want to.
It's like, here's some toast. I made it in my backyard.
Yeah, literally. Oh,
But
God.
that's basically what you do. I mean, you make it with flour and all that stuff, and I guess you just combine. I don't know. I don't know what I'm talking about.
I don't know how
I
they
don't
would
know
make
what I'm talking about.
actual edible food, like for you to eat with a 3D
Would
printer.
it taste any good?
I don't know.
Or would it taste like plastic, gummy plastic, like boba, without the sugar?
I love boba.
Without the sugar?
Well, I've never had it without the sugar.
It tastes like gummy plastic.
Ew.
Yeah. And then our next type is going to be, oh goodness, that polymerization. Polymerization. Polymerization.
Polymerization.
That.
Polymerization.
You get what we mean. I'll put it on the screen. This type is more commonly known as resin printing.
Okay.
Oh, why didn't you just say that? So basically, you have this giant pool of resin, and you got this flat thing, and it dips inside, and then there's a light underneath that draws out the design, and it hardens only that area of resin. And then it goes up, and then it goes back down to get new.
And it does it again.
And it does it again.
Huh.
And different, and then it just goes like.
You know what I've established?
What?
I think scientists just like making hard, goofy names like vat polymerization, just for us normal people to struggle.
Not be able to say it.
Mm-hmm.
It makes them feel smart.
I think it does.
I need
Which they are smart.
I need
but...
the Urban Dictionary of Science.
Yeah, pseudoscience.
Yes. But that's yeah. So powder bed fusion, or PBF, is another kind of printing, and it is a process using thermal energy source such as melt powder particles in selective areas within a building area that is done layer by layer. The material types could be plastic, metal, or ceramic. Processing.
Yeah.
Hold on, processing. So basically,
I don't know.
you have a giant tin thing of powder, and it uses a thermal energy source. So heat. It could be a laser, I guess. Thermal.
But it's so
something that heats it up in a certain little area, and it melts the powdered particles together. So that's why it has to be plastic, metal, or ceramic, because it has to melt
combined
together.
Yeah. Huh.
And I guess it just does it like a layer of powder,
I guess.
layer of power, until you're all the way up.
I guess. I don't know.
And then there's material jetting, and this is accomplished by tiny droplets of material being deposited onto a build plate and curing into a hardened state over time. So it uses photopolymers. You gotta remember, guys, I am dyslexic. This is hard. Or it uses wax. Wax would be good because it would just immediately harden once it's melted. So it would be easier if you had wax. And then when it is exposed to light, the object will cure, and then you would just build it layer by layer by layer. So it's very similar, I guess, but it's not as permanent, I'm assuming, because it's like wax.
Mm-hmm.
Wax will always melt again. It'd just be puddles. I don't know.
Again, we are not
scientists. Another one is binder jetting. This is the process used. It uses a powder material and a liquid deposited from an inkjet to bind regions of the layer of powder.
Huh.
So instead of using thermal energy, it uses liquid.
Yeah.
So it's like if you got powder and then super glue in a certain design, and so you would put powder, super glue, powder, super glue.
Yeah.
And you got a design. I want to try that.
I was about to say.
Can we try that?
I was about to say I'm gonna go home and get some hot glue and some flour, and then hot glue and flour.
I'm so gonna do that. That's my next project.
You could use glitter as the powder, and it could be all sparkly.
You know what? And it says that the materials can be metal, plastic, ceramic, wood, even sugar.
Well, I was about to say maybe that's how they make food, is the sugar. But if you have a layer of liquid stuff in between, I don't think you could eat.
Well, I was thinking
that.
hot water would melt sugar.
It would melt sugar.
And then you
But then
just have,
actually,
sugar
but it just dissolves the sugar though at that hot water. It has to be a certain temperature.
It has to be, yeah.
We're rambling. Okay.
I don't know. Next one is directed energy
Directed energy deposition.
How is that deposition? Anyway, this process is achieved by metal material being fed.
Here, I will do this one. Directed energy deposition. This process is achieved by metal material being fed, deposited, and then fused by a powerful energy source. So pretty much it's close to welding.
Oh.
So
So it's a welding printer.
yeah, that's what I've gathered.
Why can't they just call it that?
Again, scientists definitely do this
This is why
to
I'm
make it
involved.
hard for us.
This is why.
This is why I have gray hair.
This is why I have gray hair. Okay. Final one that is listed is sheet lamination, which is the process of a type of 3D printing differs from the previous discussed methods. Anyway, this method is done by stacking sheets of varying material together, and laminated.
I believe in you.
The sheets, it laminates the sheets together to create a 3D object or a stack that's then cut mechanically or with lasers to form a final project or product.
Would you like me to do this one?
No,
Okay.
because it just still doesn't make any sense. Sheet lamination, you can look it up. Basically, it is done by stacking various materials together, and then it's laminating all of those materials together with various methods, such as like heat or even sound, apparently. And then once the sheets are all together, it is cut mechanically with lasers or sharp objects to form the final product.
I want to know how they use sound.
It's too big for brain. Too big for brain. Brain doesn't work like that.
All right, our
the
last
next one
question.
on the other side.
Oh, second to last question, actually. What materials can be used in 3D printing, and how does the choice of material affect the final product?
Okay, so we hinted at this one in the last
Yes.
question, which was really hard to get through.
Yes.
Anyway, the answer to that one is it really depends on the 3D printing method, which we just went over.
Yes.
It can be variety of materials such as plastic, metal, wood, sugar, polymer resin, photopolymer resin, ceramic, or even a paste.
All right.
The types that we use here in the AMNS Calvert STEM Lab is going to be PLA, which is polylactic acid, and ABS. Okay. I will put the name up there. I'm not even going to attempt to say it. I will just embarrass myself further. The key differences between those two are the printing methods. PLA can be printed in an open environment with lower temperatures, while ABS has to be printed in an enclosed environment with higher temperatures. So you have to put like a lid over the ABS.
Huh.
Because it just, if you have air going through it, it will cool it enough to mess it up. So it has to be in an enclosed kind of like printer rather than a open printer where you can just kind of sit there and just be mesmerized
I gotcha.
the entire time.
Final question.
My head hurts.
What are some of your favorite 3D printing projects that you've worked on or been involved in?
All right, so Bruce has been involved in a lot of 3D printing projects, and honestly, they are very impressive. I love messing with them and just seeing what you can do.
They're so cool.
So his answer to that one is the dragon that he printed, which we do have, and he painted it years ago, and it definitely defines his pride and joy. And it took a lot of hours and a lot of failures to finally complete this dragon.
Time to get the dragon out.
This is his dragon, and it does articulate, it does move. I'm going to scoot up just a bit.
Oh, here, I'll zoom in for you.
Yeah, just zoom in.
All right.
Roar. But this is his dragon that he created. It is so impressive, honestly. Like, even the wings move accordingly, and you can bend them, it moves, it articulates. It's so impressive that he created this with the 3D printer. And I can imagine how many failures it took, because each part, even the eyeballs on the inside, it's amazing.
Look at the teeth.
I know.
Like, it even has the teeth.
It opens its mouth.
I think the tail, does the tail move?
Yeah, the tail moves too. He's like,
yeah.
In the body, you can mess with it if you want.
Yeah, I want to play.
Just be careful. We don't want to break his pride and joy.
No, we don't.
But continuing with his
cool.
answer, he also 3D printed a hand where you could pull the strings and the fingers would move. He was intending to use it for an exhibit for Fear, which is our current exhibit, but it had some kinks that he kind of had to work out. The hand, we have an example of right here, and this is what he was talking about. So as you pull,
Oh, that's cool.
and it just moves the fingers like that.
Yeah,
Isn't that cool?
that is really cool.
We don't want to make any rude gestures. Hang on. There we go. And then this one moves. Can you imagine this being in fear?
Oh my gosh.
It's like a hand just randomly moving and no one's controlling it.
That's cool though.
That is really impressive, honestly. But you can see how it's all connected. All of these pieces had to be printed separately along with the connecting joints. And then I'm thinking that he had to calibrate it specifically to have a hole through the middle.
Mm-hmm.
And by 3D printing personally, it is really difficult to get all the kinks out. So this one's, he did a good job with his hand. High five.
Oh yeah.
Oh man. But his favorite projects would be the projects that he does with his academy students, because he is in charge of the STEM education, not STEM education, but the 3D printing
Yes, camps.
And he has printed 2 objects where he added the academy kids to the name onto the project, which is super cute and adorable. And they both, the kids and he worked on it, which is right here. And it's this little rhino.
That is not correct.
That's a triceratops.
It's a triceratops. Why did we say rhino? It's a triceratops with a little castle on top. And it's got all the names of all the kids on here along with Bruce's name, and they all painted it. They chose the letter.
I love how it has a saddle too.
It does. It has a saddle with with the little tower on top, which is adorable.
Mm-hmm.
Inside the tower, you can see stairs going down into the entrance right here.
Yeah.
Which I think is a really neat little detail to it.
Oh yeah, it is. That's cool.
And it's absolutely amazing. And the fact that all the kids' names on there is just super memorable and close to his heart.
Yeah. Perfect little memorabilia.
Yes. His latest 3D printing project was during the Out of the Wilds Academy Week.
Okay.
These kids learned about different biomes of the earth. So different environments, biomes, things that lives in those biomes. And he created a cardboard structure that would be used for an e-tech zoo. Basically, a zoo of different animals that the kids created.
Oh, cool.
Yeah. He separated the structures into 4 equal sections for all the kids. He then had the academy kids work on a week-long zoo project. They divided into 4 groups, selected different biomes, used the game called Spore to make alien creatures for their biomes in their own unique design.
I need you to get them out.
I will.
They're so
Which they were then 3D printed, and the 3D printed various objects to fill their biomes.
so cute.
So basically, I'm assuming the Spore kind of program that they used, it took ideas, different things, like what if you wanted wings? Put wings in there. If you wanted to have horns, put horns in there. Different characteristics from different animals. All combination into one weird creature. And those were the 4 different biomes. It had to correlate with the different traits of the animals that would live in that biome, which is really neat.
It is really neat.
That sounds, I want to go to that camp, man.
I know.
Why couldn't that have been a thing while I was young? But we have a few of the creatures with
They're
us.
so cool. All right, I'm going
And
to zoom
so
in again.
we have this little guy right here. Rawr. Isn't it neat?
It is neat.
Grr.
Look at his feet.
I know, like the feet are two-toed. They're two-toed. It's got horns. It's got bug eyes. But the kids created these out of their own imagination, their own thinking, and then had to have a biome with it. But this is one of the few that we have from the kids. These others are more about 3D printing. I don't even know what that is.
A little troll.
It's a little
I
troll.
don't know if y'all could even.
Yep. But this one is looks like a Star Wars guy, but it probably isn't a Star Wars guy. He's got little wings.
He kind of looks like an alien little golem.
Yeah,
Or
same with this one.
What are they called?
I don't know.
Little things that sit on the edge.
A
Cement.
Oh, they're
Gargoyle.
Gargoyles.
It looks like a little alien gargoyle.
This one looks like a cute little dragon.
Yeah.
Little bitty wings.
He looks like he came out of Dragon Tales.
Yes.
Dragon Tales,
Dragon Tales. And then, of course, we have a Sphinx.
The Sphinx is really cool.
The Sphinx is really cool. My one that I really like is this little chameleon, and they did them in all different colors.
Yeah.
Because chameleons change colors,
I
so
love
they
that.
put them in all these different colors, and it's just so cool and neat.
That is cool. They have another little Egyptian
They have a little
man.
Egyptian man. This one's really neat. He looks like something out of there was this old cartoon I used to watch as a kid. It was Thundercats. I don't know if anyone else has ever seen Thundercats, but I loved that show.
Never watched.
It was the remake of the old show, and they, of course, ended up canceling it. But I personally loved it.
It's cool though.
But it's like this really awesome, super warrior-like cat thing.
There's all these details on the armor too,
The
and everything.
details are
It's
insane.
crazy.
And with the sword and everything, even
Yeah.
like you can see the sun on the back and like the panther on the front.
Yeah, that's cool.
It's definitely from like a TV show or a video game something.
Yeah.
But this one's really impressive with all the details. Of course, we have our
Pyramid.
little pyramids that are really neat because there's empty triangles in them. And it's hard to get those details
We
sometimes.
got another dinosaur over here.
We do, and they actually go with our Exploreum castle.
Wow.
Yeah, they go with our Exploreum castle right here. And they like to sit up here like little gargoyles and guard over our Exploreum. And then on the inside, there are actually like stairs that go spiraling down to the
Yeah.
bottom. I find that
That's
really
really
neat because
cool.
it's. Don't follow there. But yeah, these are all the creations that Bruce has made here at the Exploreum and in different camps, things that we can do with 3D printing. Honestly, there's an entire different
cool.
world of 3D printing out there. Here's
Oh,
another.
this is an actual gargoyle.
That one's a gargoyle
An
gargoyle.
actual gargoyle.
Oh, wow.
Gargoyle. Can't speak.
Speaking's hard. Words are hard. And then tiny little men.
Oh, cute.
But this is what we have for today.
Yes.
And all of our mishaps of trying to figure out how to say a lot of these words and figure out
It was a struggle, but we did it for you.
yes,
It's all for you.
yes. And Bruce is impressive.
Oh yes, Bruce.
His comprehension level is just another spectrum.
Oh yeah, no, Bruce. I was already very impressed with him, but
But now
after
it's
it's like
Whole
Oh,
another
yeah.
level.
Yeah.
Trying to figure out what he does,
I'm not
how
just
he does it. It's
impressed.
impossible.
I'm not just impressed. I always had respect for him, but like I have a
You are
newfound respect.
astounded.
Yeah, I have a newfound respect. That is
Yes.
crazy. Well,
That's it for today.
okay, that's
Yeah.
it for today. We'll see
Yeah.
y'all next time.
Thank you for watching, and make sure to like and subscribe.
Yes.
'Cause
Yes. Follow us.
Even though we don't have a subscribe yet, because episode 2, we'll get there.
we will. Bye.
Bye.